Hey everyone, in this video we are going to discuss reference angles. Okay, so in order to get started, we are going to go ahead and add in a unit circle here, which a unit circle is centered at the origin and has a radius of 1. In this case, the radius isn't really that important, but I also threw in the x and y axes in order to have a solid reference, all right, for where we're at. Now let's recall that the initial side is this side, the positive x-axis, and also we always start here at 0 degrees, or 0 pi radians if you're using radians. All right, now I'm going to show you an example first, then we're going to go ahead and define what it actually means to be a reference angle. Okay, so let's say in this example, I'm going to move along. We're going to start at 0 degrees, and I'm going to say I'm going to move, I don't know, let's say 45 degrees. Okay, so I'm going to start at 0 degrees, and I'm going to move along the circle here until I have moved a total of 45 degrees. And so if I drew my terminal side, it would look something like that. And this angle here would be 45 degrees. Okay, and so what we're really after here for these types of questions in trigonometry is this x and y value. And in order to figure out what that x and y value is, we're going to use some basic trig functions, namely the sine and cosine functions, in order to do that. And in order to do it, we are going to drop down a line, right? And this is going to be a right angle, which creates a right triangle. And because that's a right triangle, we can do some simple trigonometry to figure out that this value of this side is literally that x, and the value of this side is literally that y. And if I use some trig, then it means that if I wanted to figure out that x value, knowing the radius, and the radius is r, or is 1 in this case, then we know that the x value is the cosine of the angle theta, and that is our reference angle. And the y value is the sine of that value. Okay, so now that I've given you this kind of like example here, this reference angle, this would be theta, which is equivalent to our reference angle. So let's go ahead and define the reference angle, because it may not be exactly what you think. You might think originally, well, if this is the initial side along the x-axis here, and this is the terminal side, then it must be the angle between the initial side and the terminal side. That's actually not the case. A reference angle is the angle, whoops, forgot the s there, is the angle between the terminal side and not the initial side, but the, say, and between the terminal side and the x-axis. Now, this is important to distinguish the difference between the x-axis and the terminal side. In the example that I drew you just now, yeah, that is actually the same, right? These are identical. Okay, these angles between the terminal side and the initial side, or the terminal side and the x-axis, but that is not always the case. Okay, so let's go about showing you a different example, and then we'll further explain. Okay, so I'm going to go ahead and remove that, and let's go ahead and put in a new example. And so in this case, I am going to I'll use the example. I am going to, again, start at your 0 degrees, and I am going to go, let's say, 150 degrees. Okay, just thinking off the top of my head here. So I'm going to start here. I'm going to go up to 90 degrees, and then I'm going to go to approximately, let's call that 150 degrees. And I'm going to go ahead and draw this terminal side. Okay, so if this angle were our reference angle, right, then it would be 150 degrees. And that is too big to be a right triangle, right? And so that's a problem. We need to have right triangles, in order to do a lot of mathematics. So what we do is we say, well, no, it is between the terminal side and the x-axis. And by the way, that's just something we've chosen, and I'll talk to in a second about why we chose that. So in this case, this is 0 degrees, this is 180 degrees. And so if I went 150 degrees, what's remaining? Well, there's 30 degrees remaining. So the 30 degrees is my reference angle. All right, and again, in order to figure out, because really what we're after here is this x and y value, and in order to figure that out, we would then drop a line making this a right triangle. So that way I can use basic trig functions in order to figure out the x and the y. Okay, now you may be asking yourself another question here, and it might be, well, hang on, let me bring up my original here. So we're using this angle 45, right, to figure out this x and y value, and we're using this angle here, this reference angle of 30, to figure out this x and y value. Why wouldn't we use this angle here? Or why, and again, create this triangle, right? Couldn't we have just as easily done that? Or this angle over here and created this right, whoops, that's not very right, is it? And created, let me do it an actual straight line here. Whoops, that's not straight either. Let's do some, hang on, let me fix this a little bit. So there we go. So there's a nice straight line, and then this one here is another nice straight line. So yeah, why not use these as reference angles? And this here would be my triangle, right? Here, here, and here, and then here and here. Now, we could have done that. We could have done that. We could have chosen to do that in math, but we didn't. We chose to, I don't know if it's somewhat arbitrary or not, but we chose between the terminal side and the x-axis, not the terminal side and the y-axis. And let me show you how that would change things. Okay. In this case, the green side, let's go ahead and just show, I'm going to take out this guy right here. So in this first example, this would be, maybe this is a bad example because it's 45, but it would be different if it was anything else. 45 happens to be the same, whether it's sine and cosine. But anyway, with the green here, right? So I told you guys, right? I told you guys that the x is the cosine and the y is the sine, right? That is like our definition. And the issue is that if we decided to use the y-axis instead, then the x value would be along this side here, okay? And if I'm using SOHCAHTOA, some right triangle trigonometry, using the same thing, x would actually end up being the sine of this angle here, of this theta, and the y value would be the adjacent side here, right? And that would be this y over here, and that would be the cosine because it's adjacent. So that would be the cosine of theta. And we could have definitely chosen that, just so you guys are aware. We could have chosen that, but we didn't. We chose to all be on the same page in math. Actually, I don't know why I'm erasing that. I should leave that there. We chose to all be on the same page in math, and we chose to use this angle down here, which is always going to be from your terminal side to the x-axis, thus making the x always the cosine of the angle and the y the sine of the angle. Okay? All right. So let's go ahead and we're going to do one more example here, and I want to do like kind of like a, I don't know, a tougher one, I suppose, where you can kind of wrap around quite a bit here. So let me go ahead and remove that example, and let me grab I can't remember which colors we actually used here. Let me just see. We used pink, we used yellow, we used green, and so let's go ahead and we're going to use blue. All right. So let's do, I don't know, something a little bit more difficult. I'm going to do negative And this is not going to be a standard angle, by the way. So this is going to be a little bit different than your normal unit circles. So I'm going to do a, let's see, negative, I don't know, let's do negative 470, whatever. Negative 470, whatever that happens to end up being, okay? So I'm going to start again at my 0 degrees. And since it's negative, I'm going to go the opposite. I'm going to go the opposite way. So let's go the opposite. I'm going to go negative 90, negative 180, negative 270, negative 360. All right, and then adding on another 10. So I'm sorry, another 90. So with the 360, what is that going to be? 450. And then I've got another 20 here to get to, so I'm just going to mark this as 20. Excuse me. And just as a little reference, and I'm going to go ahead and draw this this terminal side here, okay? So that was 450, so 360, 450, plus another 20 to get to negative 470. So I'm going to go ahead and label that here, just so I can get rid of it over here. So this is negative 470 degrees. Okay, that was kind of a tough one. And that way I can erase this one over here. All right, now the question is, what is our reference angle? Well, remember, it's always the angle between the terminal side and the x-axis over here. So if this was 20 degrees here and this is 90 degrees in between, then my reference angle must be 70 degrees. Okay, and again, what we're really after here is the value of the x and the y at this point, right? We're trying to figure out what this point is, and if this is a right triangle, and I know this side, and we all agree that the reference angle is here, then I always know that that x is going to be the cosine of 70 degrees, and the y is going to be the sine of 70 degrees. All right, so there we go. That is how we produce reference angles. Here's a couple of examples up here. Remember, a reference angle is the angle between the terminal side and the x-axis, and now that we've all agreed on that, we can say that the x value is the cosine of theta and the sine, and the y value is the sine of theta on the unit circle. All right, and one little additional thing: if it's not a unit circle, if the radius is something other than 1, recall that it's still cosine and sine, but the x value is the radius times the cosine of theta, and the y value is the radius times the sine of theta. So there's an extra little tidbit there for you. All right.